Hi everyone. Okay, so this is going to be lesson 3 from unit 1, and this is the greatest common factor. So last lesson we looked at getting rid of the brackets by expanding and simplifying. So for example, you had an example like this. So we have 3 bracket 4x plus 2 bracket. So we need to bring the 3 into the brackets by multiplying it to each term. So we first multiply the 3 to the 4x, and we get 12x. And then we need to multiply the 3 to the 2, and we get plus 6. And we can't simplify it anymore because the 12x and the 6 are not like terms. So now we are factoring. So this is the complete opposite. So it's like we're going from the 12x plus 6 backwards to the brackets. So common factors. The common factors that are shared by 2 numbers or terms are called common factors. This will all make sense in a second. The largest, most complete common factor is the greatest common factor. So what we want to do is look for the biggest numbers and the biggest copies of letters that will go into all the terms. So for example, I have 12 and 20. We need to find the greatest common factor of it. So if we look at 12, we know that it can be divided by 1, 2, 3, 4, 6, and 12, where 20 can be divided by 1, 2, 4, 5, 10, and 20. That means that the greatest common factor, so the greatest one closest to our right side here, that is the same, is 4. So the greatest common factor for 12 and 20 is 4. So now we're going to be actually putting the variables into the problems too. So I have 9x to the power 4, 15x squared, and 21x cubed. So we want to divide it by a number that each one of them divides, and then we need to make sure it's the greatest common factor. Well, we can't divide, like 9 divides by 9, but we can't divide 15 by 9, and we can't divide 21 by 9. So the greatest common factor, so if 9's not going to divide 9, the next one is 3. And we could see that 3 divides each one of these. And now we need to look at the variables. So the variable with the lowest exponent is the greatest common factor that we're going to pull out. So in this case, it's our x squared. So we're going to pull 3x squared out of each one of these terms. So I'm going to pull 3x squared out of the 9x4. So what we do is we take 3 and we our 9 and we divide it by 3. So I'm pulling 3x squared from it. 9 divided by 3 is 3. And then x to the power of 4. If I'm taking away 2 of them, then there's going to be 2 of them left. Then for the 15x squared, I'm dividing it by 3. So I'm taking 3x squared out of it. So if I divide 15 by 3, so I take 3x squared out of it, I am left with just 5 from the 15. And since we're taking all of the x squared out, there's not going to be any variables with the 5. The next one is the 21x3. So we divide the 21, so we're taking the 3x squared, so we're dividing it by the 3, we're left with 7 inside. In terms of the variables, I have x3 here. If I'm going to take away x2, then we're only left with 1x. So these are the answers for all of these. So we factored each one. Okay, another example. We need to look at what each one of these can be divided by. So 4, 6, and 12, the greatest common factor for this is 2. Since 6 can't be divided by 4, it's not going to be 4, so the next one for 4 would be 2. Each one of these can be divided by 2. Now we need to look at the variables. We got to find the lowest exponent, which is this one here. It's the x squared. So we're going to pull out 2x squared out of each one. So if I'm pulling 2x squared out of the 4x3, we take the 4, we divide it by 2. So I'm left with just 2 inside. And then if I have x3 and I'm taking away x squared of it, I'm going to be left with just x. Okay, and then I have 6x squared. If we divide it by 2, so we're bringing 2x squared out, that will leave it with 2x squared and only a 3 inside, since we're taking all of the x's out. And then the last one, the 12x squared, we've divided by 2. So we're pulling 2 out, we're left with 6. Since there is a 5x squared, or x to the power of 5 here, and we're pulling 2 of them out, I am left with 3 x to the power of 3. Okay, so for factoring, these are more of the examples that you're going to see, which is going to involve addition and subtraction. So we're going to take out the greatest common factor of each term. So we're looking at the first one. What can each, first we need to figure out what can each be divided by, the greatest common factor. So the only one here that would work is 2. Each of these can be divided by 2, and that's our greatest common factor. So I'm going to pull 2 out of this whole thing. So if I'm dividing 6x by 2, I'm left with 3x. Here, we aren't pulling x out because this 2 has no x. So if there is a term that doesn't have any variables, we cannot pull variables out of the whole thing. Okay, so we pulled 2 out of there, and then we leave the sign in the middle. So plus, and then 2, and we're dividing it by 2, we've got plus 1. Okay, so for this one, our greatest common factor is 2. So both of these can be divided by 2. And now we need to look at the variables. So we need to find the one with the smallest exponent, which is x squared. So I'm going to pull out 2x squared from this whole expression. So 4 divided by 2, and then we're pulling 2 x's out of this. So I'm left with just 2x. And then for the 6x squared, I'm dividing it by 2, and then I'm pulling 2 x's out, x squared out of it. So I'm left with just plus 3. Okay, here the common factor is 5. And the common factor for variable is just x to the imaginary power 1. So I'm going to be pulling 5x out of this. So 15 x squared, taking out 5x of it, I am left with 3x. So remember, you have to divide the 15 by 5. So I've got 3. And then in terms of our variables, if I have x squared and I'm pulling one of them out, then I'm left with just 1x in there. Keep the subtraction sign here. So I'm pulling 5x, and this is 5x. So 5 divided by 5 is just minus 1. And since I'm pulling that x out, we leave it as just minus 1 with no variable since we pulled this x out. Okay, the next one, both of these can be divided. So if they're both negative numbers, we want to divide them by a negative. Both of these can be divided. Our greatest common factor here is negative 12. So now we need to look at the variables, and our lowest common one is x squared. So we're going to be pulling out negative 12x squared. So negative 12 divided by negative 12 gives me 1. and I'm pulling 2 of these out, so I'm left with just x. And then for this one, negative 36 divided by negative 12, and it's with the x squared. So since I'm pulling the x squared out of here, there's going to be no x's, and I'm left with plus 3. Okay, last example. This should be example E. So our greatest common factor for both of these, they both can be divided by 9. And now since if there are 2 types of variables involved, we've got an x and we've got a y, we need to look at both of them. So our lowest for y is y to the imaginary power of 1. And our lowest for x is x to the imaginary power of 1. So I'm going to pull out 9x1, y1. So 18 divided by 9, I get 2. And then I'm pulling an x, 1x from here, and 1y from here. So I'm left with 2x. And then I have negative 9 divided by 9. So we know that the number is going to be minus 1. And then I'm pulling 1x from here and 1y. So I'm left with minus 1y. Remember, there's imaginary 1 here that you do not need to actually show.